Hello, lovely people. I hope you're doing well. Welcome to a question on parametric equations, including differentiating and converting to Cartesian equations. So the first question says find an expression for dy dx, and we've been given that x equals tan squared t and y equals sine t. Okay, it does also say you need not simplify your answer. Great. So this is where we just use this here. We say dy dx is equal to dy dt multiplied by dt dx. Bearing in mind dt dx is just 1 over dx dt. Another way you can say it is dy dt divided by dx dt. They mean the same thing. Okay, so if we know that y equals sine of t, then dy dt is just going to be cos t. If we know that x is equal to tan squared t, then by using the chain rule, I'm going to use the quick method. We've got a function squared. So differentiating a function squared, or the outside function, gives us 2 times that function to the power of 1. So in this case, 2 times tan t rather, to the power of 1, which is just tan t. And then we multiply that by the derivative of the inside function. So in this case, the derivative of tan t. And tan differentiates the sec squared, so times sec squared t. So remember, guys, this is chain rule. So just to simplify this, is 2 tan t sec squared t. Now dy dx then is essentially dy dt over dx dt. So that's going to be, let's actually write that. So that's dy dt over dx dt. Apologies for the slanted line. I normally don't like these, but space is of the essence. So dy dt is cos of t, and that's all divided by 2 tan t sec squared t. Okay, so that's part A done. It says you need not simplify your answer, so why would we? You don't get any extra marks for it. Okay, let's see. Let's go this color. Find an equation of the tangent to the curve at the point where t equals pi over 4. Okay, so at t equals pi over 4, dy dx equals, and we substitute pi over 4. So we have cos of pi over 4 over 2 tan pi over 4 sec squared pi over 4. Right, now, pi over 4 is like 45 degrees. So cos of pi over 4, or cos of 45, well, that's going to be root 2 over 2. And that's all divided by 2, well, not even tan, 2 lots of tan 45, or tan pi over 4, is going to be 1. And sec squared, well, sec squared of pi over 4 is the same thing as 1 over cos squared pi over 4. Now, bear in mind that cos of pi over 4, as we discussed before, is root 2 over 2. So we're multiplying that by 1 over root 2 over 2 squared. Okay? So we've got root 2 over 2 over 2 times, well, 1 over root 2 over 2 squared is 2 over 4, which is a half. So like that. That simplifies to root 2 over 2 over 2 times 1 over a half is going to be the same thing as, well, if you're dividing by half, it's the same as timesing by 2. So over 4, which is equal to root 2 over 8. Okay, so that is the value of the y dx at pi over 4. Now we need to use y equals mx plus c. So we need to work out what the y coordinate is and what the x coordinate is. So at t equals pi over 4, we have y equals sine of pi over 4, which is equal to root 2 over 2. And we have the x equals tan squared of pi over 4, which is equal to 1 squared, which is equal to 1. So we can use y equals mx plus c, or we can use y minus y1 equals mx minus x1. It's up to you. I'm just going to go with y equals mx plus c. We know that the gradient m is root 2 over 8. So y equals root 2 over 8 x plus c, which is equal to, well, we don't know what it is. We're going to substitute in y equals root 2 over 2. So root 2 over 2 equals root 2 over 8 lots of 1. So that's just root 2 over 8 plus c. So therefore, c is equal to root 2 over 2 minus root 2 over 8. And if we make the denominators the same, that becomes, what does that become? That becomes times the first one by 4. So 4 root 2 over 8 minus root 2 over 8, which is 3 root 2 over 8. So the final equation is y equals m, so root 2 over 8, x plus c, which is 3 root 2 over 8. Okay, it says a and b in the form y equals ax plus b. I mean, that was our same form. And it says a and b are constants to be determined. So we determine that a equals root 2 over 8 and b equals 3 root 2 over 8. Now, they make you do this so you essentially don't just slap it into a calculator and just do the work like that. So there we go. Next, find a Cartesian equation of the curve in the form y squared equals f of x. Now, anytime you've got trigonometric equations and they're asking you to work out Cartesian equations, in fact, let's use, green's fine. Yeah, anytime you're being asked to work out Cartesian equations with trigonometric, parametric equations, you've always got to be thinking identities. Always. That's kind of the easiest way to turn from parametric to Cartesian. So let's just remind ourselves, I'm just going to write it down here, that x was equal to, was it tan squared? Yep, tan squared t. X equals tan squared t. And y was equal to sine t. Okay, great. And it says find the Cartesian equation in the form y squared equals f of x. Okay, so a few things to consider. First of all, we always look at what they ask us to do. And what they've asked us to do is get it in the form y squared equals f of x. So it makes sense to work out what y squared is. If we have the y as sine t, well, we have the y squared is equal to sine squared t. Okay, what else is there to think about? Now, the thing that I mentioned we always have to think about is identities. So some things to think about would be, well, what identities involve tan squared? What identities involve sine squared? Well, we have, for example, with tan squared, the 1 plus tan squared of t is identical to sec squared of t. Okay, this works. It's got tan squared in there, but sec squared, well, that's to do with cos, because that's 1 over cos. What else do we have? Well, there's the sine squared formula. So we have that, we have from here, the sine squared of t plus cos squared of t is identical to 1. Now, annoyingly, that doesn't have, that has the cos squared, which doesn't really have much to do with, the other equation. However, we can kind of combine these two things. I mean, bear in mind, let's look at what happens if we were to do this. If we were to divide this whole equation by sine squared, we get 1 plus cos squared over sine squared is 1 over tan squared, which is great. Or cot squared, but I'm going to write 1 over tan squared. And that's identical to, 1 over sine squared. And this is good because it involves the sine squared and the tan squared. So we have 1 plus 1 over x squared, because x was equal to tan squared t, is equal to 1 over y squared, because y squared was equal to sine squared t. Well, that's good. Okay, so this actually helps. This helps. And it just said in the form y squared equals f of x. So at this stage, I mean, we can just work out the reciprocal of both functions. So we can just write it as 1 over 1 plus 1 over x squared is equal to y squared. That's fine. There are probably other forms in which we could have written it, but this works out. We don't need to bother with anything else. This is an acceptable final answer. If people wanted a nicer, tidier version, this, by the way, is not necessary. This bit I'm just going to put not necessary, but for anyone who would like to know, you could multiply the top and bottom by x squared. So 1 times x squared is x squared over, and then 1 times x squared at the bottom is also x squared, and then the 1 over x squared times x squared is 1, and that is still equal to y squared. So it's just another way of writing that fraction without the double fraction, but it works out. It's fine. There's no issue. Okay, that is it for this video. Take care for now, guys.